Hi class, this is lesson 2 in Math Theory 2 Unit 2 on Permutation and Combination. And then today we're going to learn some new notation, a new operation in math. And then we're going to continue learning how to work with permutation and combination. Basically, it's a quick way to count different number of ways of arrangement or like combination. It's kind of interesting. Like it make you think and then like put things together, and then you'll be amazed by the power of math that can allow you to quickly count even up to thousands of numbers. Okay, now let's start with this example. How many ways are there to arrange 6 books on the shelf? Now notice the word arrange, right? So you want to put them in order, in certain order. So arrangement represent the order will count. So 6 different books. So you have 6 places. So the way to think about this is break down into stages, into different tasks. One task break into different stages. So first you put the first book in, then you put your second book, third book, and so on. And then you have this pattern 5, 6, 5, 4, 3, 2, 1. Now you realize you see this pattern all the time, isn't it? When you're arranging books or like clothes and like CD or different things, this pattern always appear. All right, is you're multiplying number in descending order. Now, since we always see this, well, mathematicians like to create a symbol for that. So when you have 6, 5, 4, 3, 2, 1, we just do this 6 factorial. It's an exclamation mark. It's like, wow, like 6 factorial. So what does that mean? It means you're starting from 6 and you multiply number in descending order all the way down to 1. So 6 factorial. So without using calculator, determine the value of this. 4 factorial is 4 times 3 times 2 times 1. So that would be the definition. All right. So that is 24. 3 factorial will be 3 times 2 times 1. All right. Times 2 factorial 2 is 2 times 2, like 2 times 1. So therefore the answer is 12. All right. So notice 6 factorial can be written in different ways. You can write it in this formal definition, and you can stop any time and you expand it. You can write it this way: 6, 5, 4, 3, 2 factorial, because 2 factorial is 2 and 1, right? And then you can write 6, 5, 4, 3 factorial, because 3 factorial is 3, 2, 1. So you can write 6, 5, 4 factorial, 6 times 5 factorial. So any factorial can be break it down like this. So the table above can help us to simplify the quotients such as this. All right. So if I have 6 factorial and 4 factorial, what do I do? First, you pick the one have bigger factorial, and then you expand it, but then you stop when you have the same factor as the other one. Now, when you work with factorial, you can't simplify, you can't like change the number, like let's say 6 factorial over 3 factorial. The way you look at them is they are together, one package. You can't do anything with the 6 and 3. You can't say, oh, 3 and 6 cancel out. No, you cannot. Because it's 6 factorial, 3 factorial. They stick together. So the only way to cancel them out is expand them. And when they are exactly the same, then you can cross it out. So for factorial, you can only cross them out when they are exactly the same. And then you find out the answer is 30 when you have 6 factorial over 4 factorial. Express 5 factorial in the different ways. All right, 5, right? 4, 3, 2, 1. 5, 4, 3, 2 factorial. So I'll finish the rest. So that's the answer. Complete the following. 12 factorial is 12 times 11 factorial. 8 factorial is 8 times 7 times 6 factorial. So again, factorial is a special operation, is a new operation you learned today. You start with the number given, and you just go keep multiplying with descending order 8, 7, 6, 5, 4, 3, 2, 1. And then there are a variety of ways to write it. There's different ways to write them. You can stop any time and put a factorial there. Now you don't miss the factorial. You can't say 8 times 7 times 6. That's not the definition. It's 8, 7, 6, 5, 4, 3, 2, 1. But then the 6, 5, 4, 3, 2, 1 can be combined into just 6 factorial. All right. So therefore, if I have this, now we see the previous example, it will be 6 factorial by what? by 3 factorial. How come? Because it's 654 and then 321. The 321 has been cancelled out. How come? Because the bottom has 321. Okay, so therefore what is this? 15 factorial divided by 11 factorial. All right? Because it's supposed to be all the way 11 all the way down to 1, but then where does the 11 down to 1 go? Because they have been divided. Okay, now why do we do all this? Because later on you'll see this pattern occur all the time. Without using a calculator, simplify the following. All right, the long way is 9, 10, 9, 8. When do you stop? You stop when it is exactly the same as the bottom one. Why do we do that? Because you can now cancel them out. So it's just like this. And then you do the math is 720. Okay, well, how about this? Okay, well, let's do a 7, 6, 5. Let's stop there. All right. And then how about the 3? Okay, well, the 3, let's expand it. 3, 2, 1. All right. The 5 cancel out. 3 and 2 is 6. Cancel with this 6. So just 56. All right. You cancel the same number when it's numerator denominator can be cancelled out. Okay. So factorial notation, they now give you a definition. In math, this is some way to define operation. You're starting with n and go n minus 1, n minus 2, which means it's the descending order, all the way down to 1. The dot 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 mean you don't know how long it could be. If it's 100, it will be 100 terms here. If it's 200, it will be 200 terms here. And n is a natural number. You can only have natural number. You cannot have 3.4 factorial. There's no such thing. And now we have one definition. How about 0 factorial? Wow, interesting. 0 factorial. And then the answer is we define it to be 1. Don't ask why. The reasoning will be given later. The reason is we want it to be consistent with all the other definition you'll see later, that we need to define it. Define means we set it like this. So actually, for definition, you can't ask why. You just accept the facts. Okay, well, let's try the following. More abstract. Okay, n factorial mean n times n minus 1, n minus 2, n minus 3 all the way down to 1. All right, and then you can stop anytime. All right, n plus 2, which means your number is n plus 2. So you start with n plus 2. And then what's the number less than n? 1 less than n plus 2 is n plus 1. What's the number less than n plus 1 is n. So that's n, and then it continues. All right, if I have this, n minus 4, minus 5, minus 6, the number gets smaller and smaller. So it starts with n minus 4, so that is my factorial. When you want to put a factorial in expression, put it in a bracket. And again, you cannot cross out any part of it. You can only cross out the whole factorial. Now let's try the following. Simplify this. Okay, looking at this, first you ask yourself which one is bigger, n plus 2 bigger or n bigger? Well, of course, n plus 2 is bigger. Then you expand n plus 2. How about the n? You don't need to. Okay, n plus 2, 1 smaller than n plus 2 is n plus 1. Basically minus 1, right? N plus 2 minus 1 is n plus. Now 1 less than that is n. And then you keep going n minus 1. But then you stop here. Why do I stop here? Because it's matched the bottom one. So my final answer is just n plus 2, n plus 1. Okay, next, which number is bigger? All right, actually the bottom number is bigger because you minus. So if you minus less, it's bigger. So n minus 1 is actually bigger, so you expand that. So the next number will be n minus 2. Oh, it's time to stop because it's the same as the one above. The smaller one you don't expand. You don't need to expand. So you only expand the bigger number and then they will be cancelled out. So here the answer is not n plus 1, n minus 1, be careful. It's 1 over n minus 1. If it's a denominator, it's remain in the denominator. Okay, so the top, you expand it, and n minus 1, it matched the bottom two things. And then now I have n minus 2, and then you just put a factorial there. Why do I do that? Because the n and n minus 1 can be all cancelled out. So the answer for this one is just n minus 2 factorial. Good. Well, let's solve the following. All right. Again, when you see this, which number is bigger? The top number is bigger, so let's expand that. And then I will stop here because that's match the bottom. All right. So therefore, the whole thing cancel out. So you have two number multiplied. together get 42. You can put everything on one side, do quadratic formula, or there's an easier way to do it. Since this must be integer, two integer, one less, right? One times the one less than itself equal to 42. So you just go through your multiplication table, which one will work? Which two number multiplied by itself will give you 42? The answer is 7 times 6. So it's more like guess and check. So therefore, you want to make sure the number is one less. So n is 7 as your final answer. All right? Good. Now, in your calculator, there's a button for it. Wow, how could it be, right? There's a button for it. So if you're using a graphic calculator, go to the math button, all right? And then when you have the menu, you go to the right until you have one, say, probability. And then you go there, and then you see a symbol for, you hit that one, and then you see one of the options will give you a factorial. Okay? All right, so when you have big number, use the calculator. All right, when you enter fraction, you know the shortcut, right? Put alpha and then the y equal. It will have a hidden shortcut menu, and then you can choose n over d, right? Which mean a fraction, and then you can use it to enter your fraction. That's a safe way to enter it. Okay, so you can do all that in just using your calculator. So you just tried it, you will see the answer. All right, now why do we learn this? Because a lot of our permutation question will have a pattern of factorial. Okay, so what permutation mean when you order things and then the order is important. The order of the arrangements is important. That is called a permutation. So now John cannot remember the SS code except it contains the digit 357. So, how many different ways you can arrange 357? You can have 357, right? 375, and then you can start with 5, and then you can have 3 7s, right? And then 7 3, and then you can start with 7. So there are total 6 ways, all right? So we call that permutation. 6 different ways to make some arrangement. So when the order is important, it is called permutation. So let's look at some example. When you want to make the arrangement for the word cat, well, there's only 3 things, right? So it's at first 3 letters, after you use 1, 2 letter, 1 letter. So the answer is 3 factorial. So when you see a pattern like this, you can write 3 factorial and you can put it in your calculator. Write the number of permutation in factorial form. Here we go. So when you're arranging n items, the answer is n factorial. So they just want to generalize it for you. How many ways you can arrange each letter? So, okay, there are 6 letters, so the answer is 6 factorial. So there are 7 letters, so the answer is 7 factorials. There's so many ways to arrange all of them. Now that's too simple. Well, how about this question? Permutation of n objects taken r at a time. All right, make sure r is less than n. So when you have 10 objects, you cannot take 11 of them, right? You can only, r is always less than n. So let's try the following. If you have the word graphites, how many 3 letters you can arrange from that? All right. So first, make sure all the letters are different. So there are total 8 letters here. Now, using our methods before, you want to make a 3 letters arrangement. You have 8 choices, 7 choices, 6 choices. This is what we do in lesson 1. And now we see, hey, this is a pattern, right? That can be written this way, which, because we see this all the time, we create a special notation for that. We call that A permutation 3. A object, you pick 3 object. So this stands for permutation. I also use the word pick, which means you carefully pick in which the order is important. So when you have A object, you only need to pick 3. You can just write the following. This is the definition, which gives you this. And then this is a button in the calculator in the same menu where the factorial is. So I will finish it off later. All right, I'll create one more lesson for this, but you can now work on the homework, learning the factorial, and I will teach about permutation again in next class. See you.